Professor Pranab Kishore Datta sir to please take his seat. I now request Dr. K.C. Mohite sir to please take his seat on the dais. Now I request Dr. Rakesh Ved sir to please take his seat on the dais. I now request Mrs. Arpana Soikia ma'am to please felicitate Professor Ghanashyam Bes sir. Thank you, ma'am. As we move to the second plenary talk of the session, it is my privilege to introduce Dr. Pranab Kishore Datta sir, who is a professor in semiconductor devices, biosensors, VLSI circuits and digital design at NERIST, Arunachal Pradesh. He earned his BE in Instrumentation Engineering from Dibrugarh University, MTech in Electronics Design and Technology from Tezpur University, and PhD in Semiconductor Devices and VLSI Circuits from Jadavpur University. Dr. Datta has over 15 years of experience in teaching and research with numerous publications in international conferences and journals on topics including low-power VLSI circuits, high-frequency oscillators, and biosensing applications. He is a member of professional bodies such as IEEE, ISTE, IEI, and IETE, and has played a significant role in advancing microelectronics and circuit design education in the region. It is our honor to have you among us, sir, and I kindly request you to deliver your talk. আহিব লাগে sir.
Pointer to come. Good afternoon, respected dignitaries present here, and it is my pleasure to share the dais with here. And for this, I thank Kendriya Vidyalaya, Jorat, to give me the opportunities to present my presentations here. First thing is, in what we have seen in the news, that everybody is now going for the semiconductors. Everywhere you see the semiconductors, and in our Assam also we have seen this one. A semiconductor lab has been set up, or we can say industry is going to coming up. By 1-2 years we'll get our ICs, which is manufactured in Assam only. Now, what semiconductor is? Now, what is this IC? Why you are going for this one? Now, first thing is that everybody, we are having some mobile phones, laptops, and all these things. Now, when you are going to purchase this, 3 things we are looking for. First things, it should give us all the applications which we wanted. Second is, it should have a very good battery backup. And third one is, it should be very small in size, and finally it should be very fast. These are some of the things which you are looking for when you are going to purchase any consumables or any product, electronics products. Now here, actually what electronics chip is. So And my talk is in a very simple way I am going to present it. That is, it is mainly for the budding researchers who are going to take this physics or semiconductor physics or circuit or finally to the product level if they want to take it as their research topic or if they want to join in some companies. Now, what is a semiconductor chip? That is what you are getting it. Okay, fine. So when you say this is an integrated circuit, when I say semiconductor chip, that it's come to the integrated circuit. So it is a small piece of semiconductor material. So when I say semiconductor material, it is nothing but silicon or germanium at the beginning when you are saying as semiconductors. So when we make this as a transistors and when we are having millions of billions of transistors in a small chip, then we are saying this is a IC, or in short way which is more famous, we are saying this is a VLSI. Okay. Now here I want to present a small video where you will have an idea what actually of PPT. This is a PDF or this one? This is PDF or PPT?
No, it's a PPT.
Not PPT. Okay. Okay, I'll put my video.
So where is the video?
Here, actually here it is inbuilt, but it is not coming. What is it?
These microchips were manufactured in a semiconductor fabrication plant like this one. Inside it is a clean room, which spans the area of 8 football fields and is filled with hundreds of machines, ranging in size from that of a van to that of a city bus, and costing anywhere between a few million and $170 million. Within this microchip factory, silicon wafers travel from machine to machine and undergo around 1,000 processes over a 3-month period. And by the end of production, each silicon wafer will be covered in hundreds of CPU chips, each containing 26 billion transistors. When we zoom in, we can see the nanoscopic transistors at the bottom and over a dozen layers of wires above. This integrated circuit is then cut out from the wafer, tested, and packaged so that it can be installed into your desktop.
So from this video, actually it is showing it what this IC is. Okay. Now when I say this one, it is finally it is saying this one, it is a comprised of millions of billions of transistors. Right. Now what is the advancement in technology? We have heard about this one, that is your IC is of 14 nanometer, 10 nanometer, 8 nanometer, and now you have seen that advertise of mobile phone. It is coming around 2 nanometer or 1 nanometer it is then. What this nanometer is actually? If you see these things, now before going to this, here if you see, at the beginning, when you are having it, that is in 1970, the IC is of 4 bit. 4 bits means now the processor which you are using it, we are saying this one is of 64 bits or 16 bit or 32 bit, then 64 bit it is coming. So if you see in 1970, it's come around 4 bits transistors, and it is having around 1000 transistor in that IC. Now this development is going on, and in 2023 it goes more than 5 into 10 to the power 6 transistor in a single IC. So huge development is there. So if I reduce this slide in this form, if you see 1970 is a 4 bit, that is 4004, 80 it goes to 86, that is of 16 bit. Then 1990 it is 486, that goes to the 32 bit. Then Pentium comes, and now after 2020 we are seeing the Apple smartphones are coming into exist. Now if you see it here, in this side, that is 1985, the size of the one transistor is, it is saying this one, 1 micrometer technology, that is around 1000 nanometer, right? And if you look at this one, that is the 5 volt supply voltage, it is there. And this is go on improvement in the technology, and if you see in 2003, that is, it is going to the 90 nanometer technology, and it is coming, the supply voltage is 1.2 to 1.4 volt. That means we are reducing the supply voltage. So, and if you go further, you will see it now in 2025, the supply voltage which a transistor required is hardly 0.5 to 0.6 volt. Now, why you are doing this one? This is because we have to scale down the device. So, when you are going to scale down the device, we have to reduce the supply voltage, because more transistors are coming in a single IC, so huge power requirement is there, huge energy is required. So to get this, to do this, what we have to do this one, we have to reduce the supply voltage. That is one reason. Another thing is the properties of the semiconductor device will vary if I reduce the size of the transistor. So I cannot continue with a 5 volt. Okay, so if you look at this one, that is which Kume's law said this one, that is, if 1 million operations is doing it in 1 joule of power, then if I have to improve it, that is 2 millions of operations if I have to do it in the 1 joule, so it will say this one, it's required around 1.57 years to do these functions. So that is going on from 1950 onwards in a linear curve. That is up to 2003 or 2007, it is happening this one. But after 2008, the scaling down of the device reduces, right? We cannot scale down at that portion. What is that proportionate ratio? It is there, that is every 2 years, the device size will be reduced to half. That means, or indirectly if I say this one, if we are using the same size of the device or the IC, that number of transistor is double. But this law, that is which you are saying this one is a Moore's law, this is failed after 2003 because of the limitation in the reductions or the shrinking of the devices. So from that, again, it has been recalculated and there is a slight changes. So what we are getting it, that to increase the operations, double the operations is required around 2.29 years. Now, why this is, why you can do it, these things? That is because of transistor scaling, which is, we are doing it, then low supply voltage we required it, smaller capacitance, and better circuit design. These are the things. Now, this is the, what is this sustainable energy system is come into present. That is, we require a less energy per computations, smaller batteries, lower cooling needs, low electricity demand, and lower carbon footprints. These are the some of the requirements which we required it. Now, how to get these things? Now, how can you reduce the power consumptions? Now, if you look at it, all the students who are studying science background, they have seen this picture, that is a single transistor, MOS transistors. Now, what actually the channel length is? Now, if you see there is 2 letters S and D, that is the source and the drain. What I said is technology, 1 nanometer, 2 nanometer, that is the distance between the source and the drain, that black portion which I am giving it, that is the length. So when I reduce the transistor means that length is reduces. So if I reduce this length, ultimately the transistor size reduces at the same proportionate in this, or approximately to the same proportionate it is reduces. Now, first when these things come into the pictures, then this MOS transistors, which we have seen it, that is, one is PMOS, another is NMOS. So indirectly, if you say this one, from a P substrate, we can make a NMOS, and for an N substrate, we can make a PMOS. That is, N substrate means it is nothing but a silicon, and which is P type, and N substrate means this is also a silicon, which is N type. Okay, so we can doing by different doping levels. I don't want to go to that part, so I'll directly move to the circuit point of view. So here, we designed a circuit using, which is known as normally, technically, if you see this one, we are saying this was CMOS circuit, right? So it is having a 2 block, we can say this one. One is pull-up network, another is the pull-down network. So what is the function of the pull-down network? It will pull the output to 0, and what is the function of the pull-up network? It will pull the output to 1. What is the output? F. Now, how this output will be pull up or pull down, that will depend upon the input combination. What is the input we are applying it? Now, this, if you look at this one, so maximum of the students, those who have studied about the science, or nowadays in the class 11, 12 also it is said this one, all of you have known the AND gate, NAND gate. So this is the circuit of a NAND gate which is designed by using a CMOS circuit. If you look at in the pull down, that is, which are in the series, two transistors are in the series, they are NMOS, and the pull up, it is the two transistors in the parallel, that is are the PMOS circuit. Now, how this circuit works, that is, if I give a 1, that is around, suppose the supply voltage of 0.5 if I am considering it, then it will be on, and pull up, if I give 0, then it will be on, opposite to each other. In the pull down, when I give a positive voltage, it will on, and in the pull up, when you give a 0 voltage, it will be on. In that sense, it is there. Now, there is, I am showing it CL. CL is the capacitance. What is the capacitance? Actually, it is the diffusion capacitance of this NMOS and the PMOS, then wire capacitance, and what are the extra circuit we are going to connect to this circuit. This will give you the CL value. Now, this CL value is very important because this will ultimately determine how much energy will require to switch on or off this device. Now, if you see simple mathematics, that is in the pull up, if you say I am connected to ground, so this is 0. So it will, what will happen? It will find the path from the transistor to the capacitor. So it will charge this capacitor, and it will, when it's fully charged, the output will be 1. Then again, when the pull down is on, it will discharge the capacitance to the ground, so it will be 0. So 1, 0, whatever we are changing it, that is when you are switching the transistor, it is going from 1 to 0, that is done with the help of this capacitance we are charging it. And if you see, what is the energy consumed, that is the thing which I want to show it, that is whatever the energy it is consuming it here, that is depend upon directly CL into VDD squared. Right, CL is the capacitance, VDD is the supply voltage which you are applying it. Now, in this case, we are consuming around CL into VDD square of energy when there is a switching. Right, now whether this energy fully it is stored in the capacitor? No. What happens if you see how much energy it is stored in the capacitor? That is only half of this, CL VDD square by 2. Now what will happen to the other half of the energy? Because we cannot destroy the energy. It is converted from one form to the another. So that other part of the energy is dissipated as a heat through the transistor. Right. That's why if you see, if you are using a mobile phone for longer duration of time, our mobile phone is heated up. Because whatever the energy the mobile phone is taking it, only half it is utilized, other half it is dissipated as a heat. Now finally, when the again output goes to 0, this will be dissipated as a heat through the NMOS part. So if you see, that means ultimately when the output is going from 0 to 1 and then again 1 to 0, we are dissipating around CL into VDD square of energy. So that's why when you are, when you see some videos continuously, more switching is there, so it is heated up. But if you read a text file, in that case what is happening, there is no, because we are just reading it, so switching is less, so it is not heated up. That is the reason, that is when there is a switching, heat will be dissipated. Now what is our aim? To reduce this energy. So how can I reduce this energy? One is that I have to reduce the supply voltage. So that's why if you see, from 1985, we are using the supply voltage as 5 volt. Now we are coming down to 0.5 volt. So it is a VDD square. So you can reduce the huge amount of energy consumption. What is the another part? It is there, if the supply voltage is fixed, then I have to reduce the CL. Now how to reduce the CL? The CL depend upon the how many transistors we are using it, how many device we are going to connect it to your device, and what is the length of the wire. These things it will depend. So how many device we are going to connect it, that is, we cannot say this one. We want more device to connect. So where I can target it, the number of transistors we are using, can I reduce it, right? So in this case, if I look at, one is this energy, another is that the on and off voltage of PMOS and NMOS is not same. So at a time what will happen, when PMOS and NMOS will be on both time at the same time. So in that case there is a direct path it will find from the supply voltage to the ground, so that will also consume energy. Another thing is that we are not doing anything, we keep the output 1, so because of the leakage there will be a current flowing through the device, right? And that is called the static consumptions. That is what you are giving you I state into VDD. So that also we have to reduce it, right? That is because always there's a reverse bias diode always forming it when you form a transistors. Sub-threshold leakage are some of the parameters which are there. Because of this, which there will be a leakage current. So total power consumption is, one is the charging, discharging, short circuit, and the leakage. So everywhere if you see, that is the CL part is come into the picture. So how to reduce this leakage? So I'll not go to the, time is limited, to the delay part. So if you look at this, in this CMOS circuit, one advantage is that the output will go to the VDD or 0. That is whatever the input we are applying it, that we are getting the output. Now, second thing is that the third point, that is what you are saying it, that is number of transistor required is 2 into number of input. That means what you have seen it in the circuit. Here if you see there is 2 input, A and B, right? So how many transistors are there? 4 transistors. That is twice this transistor. Okay, so if you see nowadays whatever the processors we are using it is having 64 bits. That means 64 we are applying as an input. So 64 into 2. So that is a huge number of transistors we require, right? So this is the general formula. So that is we are saying it twice n. So can I reduce this number of transistors? So another circuit has been developed. That is this one. So what it is doing this one, that whole parallel circuit is replaced by one transistor, that is a PMOS transistor, right? So, and the pull down, it is keeping as it is. So if I have a 64 bit, that is 64 plus 1, and 64 plus 2, that is 1 PMOS and 1 NMOS it is there. Now the operation of this circuit is little bit different. So what it will do this one, it will charge this capacitor first, that according to the input, whether it will remain in the 1 or it will goes to 0. So if I do like this, then what is happening here? In this case, the number of transistors reduces. So it is going to n plus 2. So if I have a 64, in this case we require hardly 66 transistors. So accordingly your CL value will be decreases there. Okay. So there are some issues in the dynamic gate. So I'll just skip this part. So this is further modified as a domino circuit because of this problem which is there. So an inverter has been put in above this. So normally the output will be 0. So whenever the input condition is satisfied, then it will goes to 1. Otherwise it will remain as 0 there. Now this issues can be, there are a lot of issues. So this is, we can take as a research topic, or we can take as a, that is the, as our problem, right? In this case, whatever the issues we are having it, so I have put a circle there, and there is another circuit which I have put it there in this circuit. What is the problem in that earlier circuit? There is a leakage is there, right? And the output reduces. If I am not changing the input, if I keep the output as 1, because of the leakage, the output reduces. That circle part which I am putting it, that will compensate the leakage, and because of the sub-threshold leakage which is there, that will be compensated by this gate M2 and M3, which will be acting as a stacking gate. That means we are increasing the threshold voltage of the circuit. So if I do like this, then if you see, there is a reduction in the, huge reduction in the power consumptions. So if you see the last, in the bar diagram, the last one is the circuit which we have proposed it. So if you see, there is a huge reductions in the circuit, that is output power consumptions, delay, everywhere there is a decreases in this circuit. So area is also decreases, that is how many transistors we are using. So number of transistor is reduced, means automatically the area will also reduce, right? So that circuit I am going to use to design a 64-bit comparator circuit. At a time 64-bit it can compare it, right? So, and in that analysis we have seen the power is reduces there, that is the green one is the circuit which we have designed it, that is it will reduce a huge amount of power as a delay. So we can save energy there, because energy is a big problem nowadays. Everywhere we cannot proceed further because there is a shortage of energy. So if I do this in the single 64-bit comparator, there is a huge save of energy. And finally we have done it, and finally we get this one in the form of a IC. That this IC will work like a 64 comparator which is having a high speed, as well as we are having this one as a low power consumption circuit. That is what we are saying is a low power VLSI circuit. Now this is what we can do it in terms of circuit point of view. Already a circuit is there, we are modifying it. Now, as a physics students, what we can do it, can you do something in the device level? Can I reduce the power consumption by doing some changes in the device level? So that is another part, that is which we are doing in the nanotechnology level. So that is enable solutions, right? Normally what we are doing, we are seeing this one. This is the normal MOSFET, planar MOSFET which we are having it, source, drain and the gate. That is fine. Now this gate has lot of problem, it is there. There is only one channel is there, weak electrostatic control, short channel effect, and high leakage and power consumption is there. So we cannot reduce it further. Whatever the CMOS or MOS circuit which we are having it, that is the problem. So what we can do it in the device structure, can I change this device structure? So for that, we require the help of the mathematics, we require the help of the physics. Both we have to work it, because any device which has been made it is finally designed from a mathematical equations. Now this mathematical equations, can I physically implement it? So when I'm going to physically implement it, where I'm going to implement this one? That is silicon, what we are saying this one, in the semiconductors. The concept in the mathematics, that is what you are thinking it, that we have, when you are going to produce as a product, so the physics come into there. So whether your mathematics can, this physics people can take this mathematics. So if I can combine both, right, then we can modify the device. That is what we are doing at this one. So what is the first things? If you look at this, the silicon dioxide, which is having a layer between the gate and the channel, that we can replace it, right? That part we can replace it by a very high permittivity material. Normally silicon die is having a permittivity of around 4. So if I can replace it to 16 or higher than this, so it will improve our performance. So in the second figure, if you see it here, that silicon dioxide we are replacing by a material that is called hafnium dioxide, which is having a permittivity above 16. So as you increase the permittivity of the silicon, so the capacitance of the circuit increases, because capacitance is equal to permittivity by the thickness of the material. So since the permittivity increases, the capacitance increases. So when I scale down the device, so I can scale it further, because capacitance increases there. So what is the advantage of doing this one? That is, we are going for a higher gate capacitance. Second, no poly depletions, reduce leakage. Leakage is also reduced. Now, that will also not fulfill our requirement. That also limit it scaling down. So what we are doing this one, we are going for a fully depleted SOI structure. So what we do this one, below the channel and the substrate, we put again an insulator there. So when you put this insulator in that part, so it will remove all the stray capacitance and all these things, which will increase the power consumptions, which will increase the delay. So that part we can remove it. So we can have an excellent electrostatic control, then very low leakage, and popular for ultra low power designs. That will we can help us to reduce the device up to 10 nanometer when I go for this structure, that is SOI structure. SOI means silicon on insulator. Now that is also not fulfilled. So in this case, if you look at this one, the gate is above top. This is the channel. Here silicon dioxide, here the gate is there. Only from one side, gate is there. Now how to increase the property of the device means I have to increase the control of the gate over the channel. Now instead of having the gate here, if I put gate this side, if I put gate this side, from three sides if I can control it, that means the control of the gate will be more in the channel, right? So that we can do it by using the FinFET. So now all the transistor is not MOS or this thing we are using the FinFET channels we are using it. So if you look at this figure, gate is in the top side, both the side it is there. So more control of the gate is there over the channel. So we can easily switch on or off the channel by the gate only, not because of the source and the drain region. So that leads us to the reducing it to up to 5 nanometer. Because the control is more, so we can reduce the size of the device. Now, can you go for something? That is, can you go it for controlling from all the side? First we have only one side, then we have gone three side, then can you go for the bottom also? So in the fifth figure, if you see, the gate is surrounded, that is channel is surrounded by the gate, and that is called gate all around, right? That is what we are saying this one now in this nano wires. Right, now we are not saying as a transistors or this one, we are saying as a nanowire. So that is what we are doing this one. Now when you do this, it's have a dramatical performance, and we can reduce up to 2 nanometer. Right, we can reduce this one up to 2 nanometer. That is what is we are having it now in 2025. That is 2 nanometer structures we are having it. Okay, so this is 2 ways. I am just showing it for the energy consumptions. That is, how can you reduce the energy so that our device can sustain. So one is from the circuit point of view, another is from the your device point of view, that is reduce the energy consumption by keeping control of the gate. So what you can take it that domino circuit enables ultra low power circuit, then high density computation nanotechnology allow precise control of atomic scale. Together they will reduce energy loss, material use, and system footprint. So if you can look on this two way, that is only for the point of view of saving of energy, we can have a lot of improvements, lot of things we can do it. And we can, as a students, for the students I am saying it, circuit part okay. In a BSc, we are studying about this one physics, so we can take that device part of as our research, and you can easily publish papers on this one. So all the works which I have shown it, that is already published in SCI journals. So this already published by my students, these things work. So you can also take this one as a research topic, that is from the device point of view. Because what I have seen it, when I am guiding the students, the physics, BSc background, MSc background students are very good knowledge of the device part. So they can do a lot of research, lot of things you can do it on this. With this, thank you. That's all from my side. Any questions? If there's no questions, so thank you for questions.
Thank you.
Thank you, sir, for your enlightening talk. Your valuable insights and perspectives have truly enriched this session. I would now like to hand over the session to Dr. Panchali Karmakar ma'am, who will take the proceedings forward.
Thank you, Khushbu. Good afternoon to everyone. I, Dr. Panchali Karmakar, welcome you all in this international seminar. Now, we move on to the next plenary talk, and it is my privilege to introduce Professor Ghanshyam Baid sir from the Department of Chemistry, Northeastern Hill University, Shillong. His research focuses on asymmetric synthesis, green chemical methods, and bioactive molecules. He has held multiple academic and research positions in India and abroad. He has also served as head of the Sophisticated Analytical Instrumental Faculty at NEHU. Sir, we are honored to have you with us, and I request you to kindly deliver your talk. Sir, the ice is yours.
How much you tell? Okay, 15 minutes. I've said it 15 minutes. Okay. I expected more students out here, but very few. Because the idea is having a seminar or conferences that, people get inspiration from there, people get some understanding out from there. And now I see like very few students, and I'm driving from Shillong today morning to here, and after doing so much, if I get this many, audience, I feel really bad about myself, that, why I'm spending my energy. So that's very important. So anyway, we should be happy whatever we have. So first of all, I would like to thank the organizer for inviting me out here. Because although this college is just on the way to my home, because I'm from Majuli, But I never visited this college, so that's why I have taken this opportunity to, to visit this college. So, because it is in college, so I had previously an idea that what I should speak. Like, I better decided that I should not speak too much of my research, but it should be related to that. So, and this title itself, it does not resemblance with my research also, because I don't like nano. There is a reason. Nano is changing the world, but there are too many lies in nano. Okay, so I don't want to fall into lies. So that's why I'm not there. So I'm not doing AI. Of course, bio I do something. So anyway, so I thought that, something I'll have to pick it up. So I have picked up sustainability. Okay, so I thought that our students will be also able to grasp it, what I'm going to tell. So that's why my topic is research and development, the sustainability question. So, okay, can I make it? Oh. What happened? Okay. So, in this lecture, I'm going to talk about these few, topics like what is sustainability solution, what constitutes sustainable solution, core principle of sustainable research and development, sustainable research and development in science and technology, and important concepts of sustainable chemical synthesis. That is where I used to work. Okay, so others are basically introduction, and then some selected example. I have just taken one example to discuss about that. So, what is the main purpose of this whole sustainability concept? Because UN also, they have now, World Sustainability Development Goals, 2030, they have said it, like there are 17 goals out there. So why these goals? These goals are there that because we want to save this planet, okay? That means we are not telling we want to save ourselves. Basically, we want to save ourselves to be with this planet, so we must save this planet. So, second thing is that the human habitat and life must sustain. That's why this question sustainability. So, and the environment must not deteriorate any further. So these are our goals basically. So what are our plans? Our plans are that environment must be protected. So how will we protect? There are different ways. Some of the ways just outlined out there. Then awareness for responsible action must be generated. Awareness, that is very important. I can see there are like thousands of papers on sustainable, solutions, thousands of papers, but people, the authors, they don't understand what sustainability is all about. Papers are published, okay, but nobody understands what the game is all about. So that is very important. So this awareness among the researchers about sustainability is very important. Then only we'll go to common people, okay. So then what are the challenges? Challenges that we have huge need, given the population like around 7 billion people now. We have got huge need and our resources are very limited, right? Huge population. Our lifestyle is changing like anything. Suppose today in this table you can see we have got two bottles. Having these plastic bottles, this water I can take it just for 5 minutes, and these bottles will take 500 years, minimum 500 years to get consumed. Right? So we'll have to think about that. What kind of solution you'll get it from there, right? Then market-driven economy. Now what we need it, we don't decide. Market decides. We'll go to Amazon, this, that, and just we'll see something, oh, this is very good, let's buy it. Basically, I don't need it, but I'm buying, right? But that will put a lot of pressure on the resources we have. So that we don't understand. So we'll have to make people aware about that. Then consumption-based development. Now why Donald Trump is telling India that we are putting high tariff this and that? Because people are eating and consuming like anything. Okay, all the time people are consuming. They are not worried about anything else, right? But we'll have to see that how much resource this world can generate. On the basis of that also we'll have to consume. So what are the solutions? Solutions are that resource must be optimally used, and we need, to decide what kind of lifestyle we want to have. Then quality of consumption must decide development. Quality of consumption, not the quantity, right? And the sustainability driving economy. When we are talking about economy, now we are talking about sustainability driving economy. Suppose Professor Dutta was thinking about like how that simple chip what you were using, like how saving this energy, saving the voltage, he was just lowering the voltage to save energy. So that matters. That is a huge thing, right? So then what are the tools we have it to solve it? We have knowledge. Then we have skill. Skill is just interpretation of knowledge, right? You just your interpretation of knowledge and my interpretation of knowledge can be different. So we have different level of skills, right? So machine learning, artificial intelligence, nanotechnology, biotechnology, which just related to this seminar, and smart yet sustainable. Whatever we'll have to do something smart yet sustainable. So that is, for that we'll have to understand what is a hazard. Hazard in every sphere, not only physical hazard. So what is hazard we'll have to understand. Then identification of hazards and their mitigation, how we can do it. Then awareness generation and orientation. Suppose this is an opportunity to give an orientation to young minds that how we can have a sustainable world, right? So then making sustainable solutions, the culture, right? Our action every day, our lifestyle, everything must be governed by now that only theme, that is sustainability, right? That if my action is affecting the sustainability of this planet, if we think about that, then everything is done. We don't need to worry about anything more, right? So core principle of sustainable research and development. First thing is that environmental sustainability, where we are talking about minimizing waste, emissions, toxicity, and efficient use of energy, water, and any raw materials, whatever we use. Then preference for renewable and biodegradable resources. So then economic sustainability. Because while our lifestyle is getting better and better, so that because our economy need to be, need to grow. So this economy sustainability must have cost-effective and scalable solutions, right? Long-term value rather than short-term gain. Economic sustainability has got that focus. So suppose circular economy model. Everything like, suppose water is, from sea, it is going to air, it is raining, then coming back to sea again, right? So that kind of model, here circular part has to be there. So economy also like everything, it has to be a, circular economy model. Then social sustainability, human health and society, ethical research practices, inclusivity and social benefits, those must include this core principle of sustainable R&D solution. You can see out here, because I don't have much time. I have set 15 minutes for myself. Okay, so these are like sustainable R&D in science and technology, green chemistry materials, where we talk about atom economy. Atom economy means if you are taking 10 atoms, that 10 atoms you must generate also. If you are using 10 atoms to generate something, that 10 atoms must be there in the product. That is, we call it atom economy. That means you cannot lose anything, you cannot leave it anything, from the system. So catalysis over stoichiometric reagents. So catalysis is one of the best solutions. And bio-based polymers, metal organic frameworks for gas capsules, energy storage. These are some prescription for green chemistry and materials. Then energy and environment, renewable energy, we can talk about solar energy, hydrogen energy, battery, biofuel, right? Then carbon capture and utilization, then water purification and desalination technologies. Then there are sustainable biotechnology. Basically, it is emphasizing more on enzymatic catalysis than harsh chemical reactions, because in a body such a system, you are taking everything in, no side reaction, right? But in the laboratory, I mix 5 chemicals together, there is a lot of side reaction, right? So, because these catalysts are so specific that they allow something very specific to happen. So that's why they are talking about enzymatic catalysis, biorefineries, green pharmaceuticals. So these are the way for sustainable biotechnology, right? So these are like kind of 12 principles of green chemistry: atom economy, waste prevention, less hazardous synthesis. So there are many like different stuff, but waste prevention is the most important goal. Waste of energy, waste of materials, these are the very important goals out there. So here I will specially emphasize when I am doing some reactions, my thing is that what is the percentage of yield? That is my first focus. Second thing is that am I getting the same number of atoms which I have used it? Okay, so that is atom economy. That means it is mass of the desired product and mass of the reactant must be 1, right? So then E factor, because in chemistry what we used to do is that we used to use a lot of solvents, this and that, to purify the product. In that process we used to lose a lot of, we used to throw a lot of things into the bin, right? So in that process we make the environment dirty, right? So here E factor is one of the things that if your that mass of the waste and mass of the product, if they has to be same, they cannot be different, right? So then one is called process mass intensity. If you do in a bigger scale, then total mass of everything you are doing in a reaction, there has to be, that they cannot be more than 1, right? Then one is called reaction mass efficiency. That is again, that is mass of the product and mass of the reactant into 100%. So these are the things. Now, what is the ultimate example of sustainable synthesis? This one maybe you can find some interest. You see, carbon dioxide and water. Carbon dioxide, when we exhale, then we generate carbon dioxide. As a chemist, what I can do is that carbon dioxide and water, if I mix it, I can make it just carbonic acid. Okay, this carbonic acid, can you see this Coca-Cola bottle? When I opened it, so the gas evolves because this carbon dioxide was kept in high pressure inside the bottle. Okay, so that means they are not stable, this carbonic acid. It is just carbon dioxide is liberated in. So as a human, I can do only that much in a laboratory. But you see, in the plant, same carbon dioxide and water, in presence of light, it is generating glucose. Okay? Glucose, it is forming like 6 carbon atoms, carbon bond. Because all organic thing, our existence is because of we can generate more carbons. Right? So that means we'll have to, if we can design something like that, then only basically we can make things sustainable. So our goal has to be like that, right? So I have already finished my 15 minutes. I'm just quickly going to another 2 minutes. I'm going to take that. I was doing some reaction of this type, okay? What is the reaction that is not very important, okay? That is because we, as an organic chemist, what I do, I synthesize some compounds which may be medicinally important, okay? So those compounds, now I have synthesized a lot of compounds that I'm not going to talk about. But most important thing is that I evaluated some of the parameters, reaction mass efficiency. Reaction mass efficiency, which I have given the definition earlier, that it has to be 100%. that means you are not generating any waste, if it is 100%. But in my case, I could generate around, after 6 steps, using the same things for 6 times, I could generate about 94%. That is quite an achievement actually, okay? So then, I'll go to another called process mass intensity. This process mass intensity should be all 1, okay? If you see this table, this, extreme right below corner, bottom corner, you can see 1.08. So this 1.08 means I am developing almost a sustainable method, okay? Because it has to be standard, is gold standard is 1, I am getting around 1.08. So that means this method is giving something which is very sustainable, right? So then another is called E factor. E factor gives the waste, how much waste you are generating basically. So if E factor is closer to 0, that means you are not generating any waste. And if you see again, right bottom corner, my E factor is 0.02, which is almost proves that I am not generating any waste. So that means idea is that if we can develop such method where we are not generating any waste, that means we can claim that we are developing sustainable method, right? So these are the key challenges. Life cycle assessment. Whatever we do, life cycle assessment is very important. Suppose this, I have already talked about this plastic bottles. So this life cycle assessment, whatever you are bringing to the system, can you degrade it without harming the environment? So disposal of waste, there are 2 things. One is called cradle to grave, another is called cradle to cradle. That means one is that you are generating something, you can finally bury it. Another thing is that you can again reuse it, cyclic process. So if your waste disposal is a cyclic process, that means from waste again regenerate, your desired material, then it is a very important thing, but they are very challenging. Waste to wealth. This time also you can see that, Pradhan Mantri Bal Puraskar from Jorat, one girl is getting some award, right? So that is the way, like, can we, convert waste to wealth to make a sustainable world? Then AI-driven discovery of zero waste new materials, because AI will give you a lot of information, they will synthesize based on the information available, and from there you can develop sustainable methods. Then climate resilient technologies. So these are the challenges, but we'll have to achieve this one to have a sustainable world, right? So thank you so much. Thank you for your attention. And if you have any question, I'll be really happy to answer them. Thank you so much.
A very good afternoon to each and everyone present here. Chairman sir, my dear seniors, colleagues, my good friends, and my dear students. Today I have been asked to give a talk, an invited talk, but the corresponding person, he was not able to tell me what exactly to say. So what I did is I thought, okay, let me keep a theme which is based on the theme of the seminar. Yes, my topic is entirely different, my way of working is quite different, but I am trying to align it with AI. The most intelligent system, what we always say, but I believe we need to put something to an AI to make it active. Yes, my works are basically based on communications. Communication, yes, it can be different types of communication. I commute with my friends, you commute with your friends by using some coding, some languages. And at times it happens that this communication has some glitches. And these glitches, we temporarily use it and say it is a technical glitch. But what is this type of glitching? Now when we want to say, we have at times so many conditions that are responsible for having a glitching. And we simply say that, yes, the cable is not working, this is not working, that is not working. But basically what it is? it is not one particular content which is responsible for communication. There are n numbers of systems, there are n numbers of technical reasons why communication fails. And I am in my way of study, and I am not a complete person who is an expert in this field. What I'm trying to do is I'm trying to find out what are the different reasons that may give a mistake in our communication system. And then in my work, I've been working with a group of my scholars, and then I found that one of the most responsible topic is stimulated Brillouin scattering. What is it? What is Brillouin scattering? Actually, Brillouin scattering is not something which is not very known to us, but it is a topic which internally, indirectly hampers our communications. As I have told you, there are so many types of communication, and each and every one of the topic are responsible for giving a misconduct in our communication. And my topic of research is stimulated Brillouin scattering. What I'm trying to cope up, what I'm trying to make it easier for AI. Now, to start with, I will use a few topics. I'll of course have to scrap some of the portions, but basically I want to discuss what is introduction, what is the fundamentals of SBS. Ekon slide move on I go to. Yet slide con move on I. Yeah. Okay, hobo. Enake hobo. It's okay. Hobo. So, introduction, then what is SBS? SBS is nothing but, it is a phenomenon when we send a particular phase of light to a system, the system responds back. Like when any new things comes, we try to oppose it. We never think it is good or bad, but we try to oppose it. And similarly, SBS is a phenomenon, stimulated Brillouin scattering is a phenomenon which interacts with or which backscatters with the optical phonons. Now, why is SBS important? SBS is important because in an AI infrastructure, we need so many things to be handled up, to be coined up, to be successful in getting a proper optical communication for long distance, which is being now commuted nowadays, because communication is the basis of all informations. Unless and until we are informed, we'll never know that what communication is. As for example, before we use the phone, now we use the WhatsApp, and that WhatsApp can send n numbers of people the information at a particular period of time, which is known as communication. Now, there are so many nonlinear effects. Nonlinear means it is not only this light which is traveling in a straight line, but it is the light which is nonlinear. At the same time, it has so many phenomena, and each of the phenomena, they execute different properties. Light, it may be self-phase modulation, it may be cross-phase, it can be four-wave, it can be Raman scattering, and it can be stimulated Brillouin scattering, what I am going to discuss it now. And this figure shows that whenever we put a high power laser, these are the particular phenomena which usually occurs here. Now, as I have told you, stimulated Brillouin scattering is nothing but it is the force, or it is the backward scattering which oppose the signal passing through it. And what we have to do is, we have to face it in such a way that it does not hamper the signal which is traveling over the surface. Now, there are different types of scattering, stimulate and Brillouin. I think everyone knows about stimulate and Brillouin. Stimulated is spontaneous, spontaneous is automatically, and stimulated is what we enforce the power and then some amount of power comes out. Now, interaction, this is the particular mechanism through which it works. Some of the basic equations are, these are the equations, what I am using it, so that we get the threshold power. Threshold means the minimum power which we get after which this backscattering process arises. In a very simple way, it is the opposing of the signal which comes to travel a longer distance, because our aim is to make a signal travel a longer distance. So these are some of the effects. That is pump power, which is the input power, and probe is after the threshold is received, the signal passes for higher order communications. For a single mode, I'll try to skip it. Okay, now where does AI works? It needs a huge infrastructure, which means that so many information should reach a point which can be manipulated, which we can control it, which we can tune it, so that the signal passes very nicely. Of course, this is a communication. What I'm very happy to see the guys coming back to the auditorium. And this is a form of communication, maybe because of some event along with the faculties, they have joined us. And it is really nice that you all are communicating in one or the other way. Now, there are so many challenges. Challenges may be like the signal may not integrate. Integrate mane log ni dibo pare, may not be of the same phase, amplitude. And these are a mitigation technique. What is a mitigation technique? Mitigation technique is nothing but all the informations we collected to a point, we form a particular structure, and from that structure, what happens is we try to make it in such a way that we get the output in a very, very positive way. So now our aim is to reduce this backscattering process. So how we can backscatter it? We can backscatter it by putting the input power, increasing the core area, increasing the acoustic damping, and applying some temperature. Here what we are going to do basically is, we will see that temperature also has an effect. If we go on heating or if we go on putting a signal for a longer distance, it may happen that due to so many regions, the temperature, the system, the optical fiber might be heated up. And once it gets heated up, so many anomalies may strike, which may degrade the communication system. As a result, we have to design the optical fiber, we have to use a fiber which has low loss, which has larger core area, which has multi-core, so that each and every signals can pass in their own core with very less number of modes. So the next is, actually I have a number of slides, I'm trying to script it up. So these are certain real-time monitoring. So whenever we try to do a system, what we have to do is, we have to put it through a sensor, the machine learning process, the machine will, actually it is not a machine, it is a software. So what a software will do is, it will manifest it, it will bring it to the proper guidance, and along with respect to the line width, this will try to increase the significance of the signal for proper traveling. So there are a number of future research directions, like it can be used for advanced materials. If we can suppress the SBS system, if we can suppress few of the nonlinear system, and we can use the hybrid amplification and so on. So I'll discuss it at last. Now let me take a simple case study. This is a part of research work by one of my students along with me. So I will use it as a case study. I'm not going to use it as the topic says it is with respect to AI. Therefore, I will take a simple case study. I'll take the topic as a case study. I will study the threshold. Everyone knows threshold is minimum point after which it will come back to the original direction. This is one with respect to temperature. This is how we can reduce the power loss, because our main aim is we have to reduce the power. If we can reduce the power, we can do so many things. The signal will not lose its integrity, its solitary behavior, and it will move through a longer period of time. So these are some of, I have done the experiment, of course, not me directly, my student and me. We have studied it for Stokes wave. I think so many of students are familiar with it. the threshold power, and we got n numbers of relations. This is the same figure what I am going to show. The second figure is the zoom of the first part, which is coinciding, and then we find that at a particular point of time they coincide. That means at that particular point the loss seems to be same. Therefore, similarly, this is also another one where we are using the threshold power over the fiber length. Now, what is the fiber length? Fiber length is, our aim is basically to throw the signal, to throw the words, to throw the informations to a longer distance. So, we might have so many glitches. To remove this, we have studied with fiber length with respect to the threshold power and fiber length, and we got that at a particular point it becomes saturated. So these are some of my works, and with respect to this we see that at this particular point we have so many discussions. That means so many things come out, like if the temperature, there is a change in the temperature, it might enhance the gain and lower the threshold, because we have to lower the threshold at any point of time. Similarly, enhance light and interaction, because that is our motive. It should stabilize the power near zero, emphasizing thermal management, because temperature is also one of the most important phenomenon when a signal is traveling. Next is, we have to moderate, we have to control the temperature, nonlinear loss, because loss is the main thing what actually hampers our basic system. Next is, it maintains a reliable performance under varying environment conditions. So it is not only that, we should see the environment, because environment also has a lots of impact. If the air is polluted and we send a fiber towards it, and if by any mistake the fiber is also polluted, it has a very motive that it might be affected by this. There are so many future scope, what actually, even though I'm doing with my PhD scholars, but still every day I read, every day I find so many things are yet to be found out. And so many reasons are there, what really basically depends and what really basically makes the system more robust. So we can, at a particular period of time in the coming days, we can use the AI system so that it can accumulate all the informations, we can give them, and then we can say that yes, we want this, and then it can be calculated. So what is the limitations? There is a limitation in communication if stimulated Brillouin scattering is not controlled. Then there is opportunities of technology, because whenever we say a fiber, the fiber may be believing that only refractive index is only responsible, but no, there are so many responsibilities. It may be a soliton effect, it may be a photonic crystal effect, it may be self-focusing, it may be cross-phase modulation, and so on, and numbers, what is still to be studied of. So these are my few references, and these are my group of students who are working on it, of course in different fields. Two of them, they have been awarded, two of them have submitted, and four of them are in the verge of submitting their thesis. So these are few of my publications, and of course I didn't include all the publications. With this I conclude my speech. Thank you. Any questions to be asked, please let me know. Any questions? Okay, then I'll give you a question from, I'll tell you a solution from myself. All the students nowadays, this is basically only for the students, of course any interested faculty is also welcome. This is for the students. See, you all are used to playing the mobile games. If I'm not wrong, at your age, this is very openly used. But why don't you use the softwares and then make the most of it? Because once you play with the software, Yes, Arup sir is also playing in the software, and there is a particular link. If your principal sir is there, or even Aparna ma'am is there, Gayatri ma'am is there, I would suggest you that we don't need to buy nowadays softwares. The softwares are very costly. The softwares I usually use is 7 lakhs per year without GST. Yes, but you know, the government has done, I don't know about other things, but I would specifically say there is a link called iSTEM, and if any of the faculties are interested, students, of course, I'm addressing the students, that if you are interested, if you want to play with the softwares, please go for the iSTEM link. This is a link where you'll get thousands of softwares free of cost. Otherwise, when you write a paper, we cannot give the name that I'm using a COMSOL multiphysics, I'm using numerical FTTD. But if you go, if your college register with that particular link, you will get n numbers of softwares. And this is what I came to know, and I want to share with you all because I know all of you are very good in mobile games. Of course, I'm not used to it. Yes, all of you are very much interested with the mobile game. So instead of giving some money to others, why don't you use the softwares, do something for yourself, and you'll see fantastic things coming out. This is really very interesting, and every day this keeps motivating me. Even if you ask me now, ma'am, how did you do this? Maybe I'll not be able to answer you. But yes, if you study the different types of softwares, because one or the other I know will definitely make you fascinated, will definitely give you interesting things, and you can do so many things in as a whole. Next, one more question that usually is asked is, how do you confirm that in a theoretical or in a computational simulation, how do you know that it is right? It may be wrong also. Good, one thing I'll tell you, if you want to do that, use the software, use some wrong information, so you'll not get the same graph what you get it earlier. Even I think so those who are working in software, sirs, maybe you all also are used to it. If you are using some wrong codes, it will not give you that particular figure. But if you are doing the right words, if you do take an example, work it out, you will see if it is working, means your software is working. So this is my earnest request to all the students of physics, chemistry, maths, and that is all I have to tell you. I have so many things to say, but I know there is paucity of time, so I'm keeping a little bit constrained, and wish you all the best. This was a very nice conference conducted by Jorhat Kendriya Mahavidyalaya, from the hosting, from my coming, receiving me, keeping me comfortably, and the memories I carried 30 years back, I still got it, found it here, for which I'm really thankful to Gayatri Ba, Arpana, and all my juniors also who are there. And thank you, everyone. Thanks the organizing committee. Thank you, sir. Thank you. Sir.
Thank you, Professor Pukun, for the inspirational speech. During my early college life, we heard about optical fibers that is going to do miracle in future. Now, good to see now things are coming into reality slowly. I think she is mostly focusing on energy efficient technology development like this. So we have our next group of presentations. For this, we are fixing 5 minutes presentations because of the time constraint, and 2 minutes will be for question hours. So entire things you are all are requested to finish within 7 minutes of time, if possible. So second group is Antari P. Hazarika, Anamika Gogoi, Priya Bora, and Jiban Soikia.
And my fellow participants, a very good afternoon to you all. Today I am here to present a research paper titled Green Synthesis of Silica Nanoparticles from Unreported Indigenous Plants and Study of their Photocatalytic Activity. Myself, Antarip P. Hazarika, one of the co-authors of this paper, and other co-authors are Anamika Gogoi, Priya Bora, and Jibon Soikia from Jagannath Barua University. So these are the contents. So water pollution is a ecological threat which is caused by discharge of toxic pollutants into the water bodies. And a major contributor in this case are the industrial wastewater. Now it has become a serious concern worldwide, and a main source to this industrial wastewater are the dye pollutants which are widely used by many industries such as textile, paper, cosmetic, etc. Every year, approx 40 to 50,000 tons of dyes are released into the water bodies, which contributes to about 20% of the industrial water pollution. So this dye-contaminated wastewater poses significant threat to the environment and also for human health. Therefore, finding efficient ways for water treatment is essential for 21st century. And in this regard, we can consider the role of photocatalysis. It is an easy, efficient, and promising way of degrading dyes and other pollutants from wastewater. Now, silica nanoparticles are one of the favorites of many researchers because of its unique characteristics such as high surface area, stability, tunable pore size, biocompatibility, and surface reactivity. SiO2 nanoparticles have various applications in different fields such as drug delivery, like medical fields, agriculture, and environmental remediation. Also, we should note that the nanoparticles, SiO2 nanoparticles, there are a wide variety of methods to produce SiO2 nanoparticles, such as sol gel, microemulsion, green synthesis, etc. Among these synthesis methods, green synthesis offers several distinct advantages over conventional methods. Green synthesis method produces nanoparticles that are biocompatible and highly stable. This is a very simple and environmental friendly process, and it offers safety, reliability, scalability, simplicity, and it uses inexpensive technology during the production. Additionally, the nanoparticles produced by this green synthesis method are comparable to those of conventional chemical methods. In this current study, we have synthesized silica nanoparticles from 7 local plants and also treated their potential as a photocatalyst for methylene blue dye under solar irradiation. Now I would like to call Ms. Priya to give information about the sources and synthesis process.
Good evening everyone present here. These are some native plant sources that are present in our northeastern region. This is the synthesis process. First, we sun dry our source, then wash the sample multiple times with distilled water, then dry the sample, sun dry, then grind these samples into small pieces, then we treat this dried sample with 1 molarity of HCl solution. Then the mixture, we transfer to a magnetic stirrer at 50 degrees Celsius for 1 hour. Then we filter this mixture with distilled water until to neutral the pH. Then this mixture we dry in the oven at 60 degrees Celsius. Then transfer this dried sample to muffle furnace for calcination at 500 degrees Celsius until we get the white silica nanoparticle.
Now let me come to the results and discussions. The first is the XRD analysis. Here you can see the broadened peak at 22 degrees, which confirm the production of amorphous silica nanoparticles. And also there are some few sharp diffraction peaks, which suggests the presence of small amounts of crystalline silica in the samples. We also did SAM analysis of the samples, you can see here, and this is the results of the photocatalytic activity. It is explained through pseudo first order kinetics and examined using Langmuir-Hinshelwood kinetic formula, and results are very promising. As you can see here, the rate constants, it ranges from 0.0173 per minute and goes to around 0.0265 per minute. And also the efficiencies, highest efficiency we got is around 94%.
Finish up in 20 seconds. Finish up in 20 seconds. The time is up. Okay.
And we got the highest efficiency around 94%. So now I'm coming to the conclusion. So XRD spectra analysis confirmed the successful green synthesis of the amorphous silica. All the silica nanoparticles showed good photocatalytic activity under solar irradiation against methylene blue. The rate constants ranging from 0.01122 to 0.0265 per minute, and degradation efficiencies ranging from 69% to 94.2%. Here the S5 sample exhibits the best photocatalytic performance among all the samples, as demonstrated by its highest rate constant and degradation efficiency. Thank you.
Thank you, Mr. Antari P. Hazarika and his team. Good. Any questions from the audience? Anyone's?
Yes, ma'am. Which one, ma'am? Around 1. This one? So this showing the degradation of concentration actually.
What about the others? Others are also coinciding?
Yes, ma'am. That is the starting point. So concentration is declining over time.
What does it signify? What is the meaning of it? What does it signify?
It is showing the degradation basically.
So is it important for your topic, or it's not that important?
Yes, it is.
Is it
important.
positively
Yes,
taken? Okay. I cannot see the other line, so I thought.
No, ma'am. That is the first concentration, initial one.
Okay.
Then with time it is degrading.
Okay.
So we got to know the kinetics by studying this.
Okay. It's okay. Thank you.
Thank you, ma'am.
Thank you. Any more questions? No. Okay. Our next group will be Ms. Novanita Sutia and Mohammad Kamaruz Zaman. They're present. Then we can go for the next group. Next group is Eliana Dutta, Dr. Mosami Madhav, and Nicola Isani Boitya. They are also absent, or? Pubali Dihinga is here? Yeah. Okay.
Good afternoon, everyone. My name is Eliana Dutta, a research scholar from Toklai Tea Research Institute. Today, I am going to present my findings on the topic soil microbial dynamics associated with the Fusarium dieback in tea plantations of Assam. This is the content of my presentation that I am going to cover today. Moving forward, what is tea? Tea is a majorly commercially cultivated plant which is not only enjoyed worldwide but also affordable at the same time. It is typically made from 2 leaves and a bud. In Assamese, we call it etikoli dutipat. However, there are various issues related to the tea plantation. Some problems are such as tea being cultivated monoculturally, it is vulnerable to various pests and diseases. In tea field, there are various pathogens that lead to the tea plant disease that reduce their productivity. The conventional way of treating such disease basically relies on the chemical pesticides and fungicide, which is not only hazardous to the environment but also increasingly unsustainable. So what should we do? We should have a very basic solution, that is, we should shift towards a more eco-friendly and sustainable approach, that is the use of a biocontrol agent. In soil, naturally there are various beneficial organisms that has antagonistic potentiality against fungal pathogen. So we need to exploit such organism because that will not only mitigate the disease but also will be environmentally safer, so it will be a win-win situation for the agriculturist. Moving forward, the dieback is a disease that starts from the tip to the root. So we go to the field and we collect the infected twigs, then we bring it to the lab and we surface sterilize it with 1% sodium hypochlorite because the Fusarium is an endophyte. Then we plate it in a PDA agar and we incubate at 28 degrees Celsius for 2 to 3 days. Upon growth, we allow it to have a pure culture. Once we get the pure culture, we observe it in a microscope because Fusarium has a distinctive macroconidia and microconidia, which is of boat shape, containing 2 to 7 septa, and microconidia is of kidney shape. Once we get the confirmation for Fusarium, we follow this protocol for isolation of the microflora in the natively present in the soil environment. We collect the soil from the tea state and we serially dilute it, and then we plate it in a selective media. After that, we incubate at desired temperature and desired time required for fungus, actinomycetes, and bacteria. Then, once we get the plating result, we observe it in a microscope and we calculate the CFU per gram. So this is the graph showing the microflora that we have obtained from both the disease-infected zone and the healthy tea zone. Here you can see that in disease-infected zone, the fungus is really very dominant, and important and beneficial organisms such as actinomycetes is really very low. However, in case of the healthy tea zone, you can see that actinomycetes and Pseudomonas fluorescens bacteria is higher. So this might be an indicator that because of presence of such important organism, this disease is not being able to spread. So from healthy tea zone, we have collected the actinomycetes, 5 actinomycetes strain completely based on their macroscopic and microscopic observation. These are the strain, their colony characteristics, gram staining, and the pure cultures. This slide exactly prove our hypothesis, you can see against the control plate that these actinomycetes are somehow being able to control the disease. That is, they are not allowing the fusarium to grow till the edge of the Petri plate as compared to the control plate. From that, we have calculated the percentage of inhibition. Once comparing the percentage of inhibition, you will get to know that the strain ACB1 is showing higher percentage of inhibition against the 3 types of fusarium fungus, which is known to cause fusarium dieback in tea plantation. So at the end, we can conclude that the microflora we have collected from the soil has antagonistic potentiality, and out of the 5 morphologically different actinomycetes, ACB1 has higher percentage of inhibition. Further, we have gone for the molecular characterization and found that this strain belongs to the genus Streptomyces. Now we are initiating a field trial in the Gabor Parbat tea state because our future perspective is to make this agent as a full-fledged biocontrol so that we can spray in the field to mitigate the fusarium dieback disease. At the end, I would like to put my acknowledgement to Dr. Venkata Senselvraj, the Director of TRA, Dr. Mosumi Madhav, my project in charge, and NTRF for funding this project and giving us the opportunity. Thank you and have a nice day. It was my one step towards saving your cup of tea.
Thank you, Eliana, for completing right in time.
So good afternoon, everyone.
Please.
Good afternoon, everyone. Myself, Pubali Dihinga. I am working as an assistant professor in Jorhat Engineering College, and currently I am pursuing my PhD in Jagannath Bora University under the guidance of Dr. Jiban Soikia. So today I am going to present my work on sustainable synthesis of cerium oxide nanoparticles from Northeast Indian plant resources. So these are the outline of my talk.
Students, please keep quiet.
So before moving to the topic, let me ask you a simple question. So do you have any favorite color? Like red, yellow, blue? I think everybody has a favorite color, right? Yeah. But can you imagine a life without any color? Like white dresses, no tempting food, or no colorful festivals. It's quite boring, right? So to make our life colorful, different industries like textile industries, food processing units uses dyes in very large amount in daily basis. And the wastage from these industries, which contains dyes in very high amount, they put it in river bodies. And I think everyone will like a light pink sari, but no one will like a pink river, right? So these dyes in the water bodies in high concentrations create respiratory problems, and they are very toxic to the aquatic life, and they reduce light penetration in water. And to mitigate this problem, different preventive measures have already been taken. People are using advanced wastewater treatment system, and also now people are using eco-friendly dyes which are derived from different plant-based products like plants, fruits or flowers. Among them, one of the very sustainable and eco-friendly technique is to use nanotechnology-based photocatalyst for dye degradation. Here, in the photocatalyst, they absorb light from sun, and they separate the electron and holes and create free electron hole pairs. These electron and holes, they produce reactive oxide radicals which degrades the dyes into different eco-friendly products like water or carbon dioxide. Metal oxide are very well-known candidate for photocatalyst. Depending upon their band gap, they can absorb light in different wavelength, like from UV to visible region, and they are very chemically stable, and they can be recovered and reused multiple times, which makes them environment friendly and cost effective. Rare earth elements which have an interesting electronic structure, their oxide may also play an active role in photocatalysis. For example, cerium with two oxidation state, they shows very high redox activity. The nanomaterials can be synthesized using two approaches like top-down and bottom-up, but these approaches mainly requires very high temperature and pressure and also toxic chemicals, and it may generate hazardous byproduct. So, but one technique, which is green synthesis technique, where plant-based extract it used for synthesis of nanomaterials, it is very environmental friendly. Here, extract from different plants can be used mixed with precursor salt to synthesize green nanoparticles. These are some reports which are shown, which are reported using Siku and Indian mulberry. They have synthesized cerium dioxide nanoparticles, and these particles are showing very active, good degradation and antimicrobial activity. Here I have used two different plants. One is water hyacinth, we commonly known as meteca, and red spinach, which we know morissa. Each sample we have taken we have separated in two parts. One is we have freshly collected leaves were grinded, which we will refer as wet sample, and we have dried some part which we refer as dry sample. This sample were calcinated and pale yellow color nanomaterial has been synthesized. The XRD report shows very good crystalline synthesis of very good crystalline cerium oxide nanomaterials. With for red spinach, we are getting crystallite size from 1.5 nanometer and 13.33 nanometer. And for water hyacinth, we are getting crystallite size 13.5 and 18.22 nanometer. UV visible spectroscopy shows absorption near 300 to 340 nanometer. From Tauk plot, we have obtained the optical band gap is near 3 eV. So we have successfully synthesized cerium dioxide using red spinach and water hyacinth, where the crystallite size are XRD peak shows confirms the very good crystalline synthesis of very good crystalline nanomaterials with crystalline size from 13 nanometer to 18 nanometer. And from UV visible spectroscopy, we have estimated the band gap is near 3 eV. At last, I would like to acknowledge my supervisor, Dr. Jivan Soikia, and Dr. Avinash Das for guiding me through this research. And I would also like to thank Jorhat Engineering College and Jagannath Barua University, and to my friends Faiz Ahmed and Olive Hazarika. And I would also like to thank my lab mates and colleagues for supporting me during this research. Thank you. Any questions?
Comes into our mind that what makes nano so special. So by looking at the picture on the left hand side of the slide, we can clearly see that almost in every aspect of our life, from medicine to electronics up to energy, the nanomaterials, or you can say nanotechnology or nanoscience, has been influencing us. And because of this plethora of applications, these nanomaterials have ultimately contributed to a sustainable development and good health and physical well-being of our human. Since my work is totally based on 2D materials, so therefore I have just given a brief overview of nanomaterial classification based on the dimension. And to define the 2D materials, these are the materials which have 2 dimensions outside the nanoscopic range, that is from 1 to 100 nanometer. Moving on to the focal point of this presentation, that is energy storage. Since these nanomaterials have very unique properties at this level, they are used to solve one of the major challenges of today's era, that is energy. And why energy storage is no longer an option but a necessity can be simply explained by today's seminar also. I can see that everyone is using their phone. It's because that they know that they have some sort of energy left in their phones. That's why they are using the device, as they know that it will work for the rest of the day, isn't it? That's how that energy storage device, simply the battery is controlling our life a little bit. Therefore, with the urbanization, industrialization and civilization, the energy demand has been growing, and with rapid increase in energy demand, we need an efficient energy storage system. And in order to meet that requirement, energy storage devices need to be very stable and they need to be very sustainable. This refers to that they should be low cost, economic and run for a longer period of time. And there comes the nanomaterial in the picture. Because of their unique properties, they can be used as energy storage devices. Recently, scientists have been exploring this kind of materials ranging from 2D materials, MXenes, and their synthetic rootways. Moving on to the next slide, here I have picked 3 different energy storage devices, namely battery, fuel cells and supercapacitors. So they can be compared based on 3 key parameters, and those are energy density, power density and commercialization. Energy density refers to how much of the energy they can deliver, okay, and device can deliver. Power density refers to how fast the energy it can deliver, and commercialization refers to how well established it is in the marketplace. So if we compare all these 3 things, battery and fuel cells have higher energy density as compared to supercapacitor. In case of power density, supercapacitor lies far above as compared to other 2. And in case of commercialization, battery is very well established in the market, while supercapacitor found in niche market as well, and the fuel cells are still emerging. Now moving on, my work is on one type of supercapacitor known as pseudocapacitor, and it is purely based on the redox reactions that occurs on the electrode surface. So this pseudocapacitance arises because of 3 mechanisms which are shown in this diagram. One is because of underpotential deposition, one is because of redox capacitance, and another is because of ion intercalation capacitance. So the main thing is that this pseudocapacitance arises because of certain elements. These are metal oxides, metal sulfides, metal nitrides, etc., and they can achieve higher energy density and specific capacitance. Now, why 2D materials are very attractive for this energy storage application? As I have already discussed, why they are promising because of certain properties only, and those are high surface to volume ratio that provides a higher active surface area. Layered architecture means they have layered structure which has gap in between, so ion can intercalate in between them. Tunability means their properties can be tuned, and higher energy efficiency. So ultimately, in the current research world, these 4 2D materials have been explored highly, and along with the exploration, challenges come up. So these challenges which have been faced or addressed by the scientists are risk-taking of 2D seeds, that there are aggregation of the 2D seeds means there is no space in between them. They will aggregate and the surface area will decrease. They have low structural stability, low intrinsic conductivity, and the synthesis procedure or synthesis is limited up to our chemistry labs only. So now moving on, these are the few published work on the 2D materials for our supercapacitor application. I have chosen nickel aluminum LDH, layer double hydroxide, and molybdenum sulfide as the composite. For the synthesis of the composite, I have just prepared this precursor separately, one via hydrothermal process and another via simple room temperature synthesis, and it is a precipitation type reaction. Further, after producing this precursor, I mixed it through a refluxing setup and the composite is produced. But after all this hard work, one question may remain in your head, that is, why this composite? Why I choose that composite? The factors are that it is economic since aluminum is low cost. Another one is that because I have chosen nickel aluminum LDH, although this kind of composite have been explored in photocatalytic activity, this composite gives a mechanical robustness to this system, means they will not degrade after lower number of cycles, they will last long. And because of that composite, the surface area increases, which will enhance the electrochemical activity. So these are the reasons why I have chosen this composite. These are the structural data that I got through XRD, and the XRD data matches perfectly with the literature, and so I can conclude that the precursor have been synthesized as well as the composite also, since composite contains most of the peaks from the precursor. Moving on, I have done some preliminary electrochemical study of one of the precursor, that is nickel aluminum LDH, and from these things I have calculated the specific capacitance, which is found out to be 419 farad per gram and lab mates, for helping me throughout my research. Thank you.
Thank you, Alipe. Nice presentations indeed. and good work. So, any questions from audience?
LDH. So it is a layered double hydroxide, means there will be two layers of metals, and in between that there will be anions intercalating. Since I have prepared nickel and aluminum LDH, so there will be two layers of metals and there will be intercalation of anions which will be present from the precursor salt. Let's say if I use carbonate salt, then carbonate anion will be intercalating in the space of layers. So I have studied only for one precursor, not the internal resistance, but the bulk resistance and the total resistance, and it has come out to be 5.08 ohm for the nickel aluminum LDH. So it is for one composite only. So I will try for another composition also. Whichever I will get the best result, I will take that and make the composite.
What about power density?
What is?
What about power density?
So power density and energy density I have not.
Oh, you have not studied yet?
I have just done the preliminary data only.
Okay, thank you.
Thank you.
Okay, thank you. Next participant, Uspandita Phukon and Projita Das. Are they available here? If not, then we can go forward with Samir Jaiswal.
Good evening, everyone of the session and other dignitaries and my fellow men present here. I would like to sincerely thank to the organizer for giving us this valuable opportunity to present the seminar on such an important platform. I am Ms. Uspandita Phukon and my friend Projita Das from the Department of Zoology, Jorhat Kendriya Mahavidyalaya 6th semester student, going to present our seminar on the topic Pollution Control in Aquaculture, Traditional versus Modern Approaches. Now I like to give a brief description about aquaculture. Aquaculture is the practice of farming aquatic organisms such as fish, prawns and crabs under controlled condition. With increasing population and declining natural fish stock, aquaculture has become an essential source of food, employment and income. However, rapid expansion of aquaculture has created serious environmental concern, particularly water pollution. This presentation focuses on pollution control in aquaculture by comparing traditional and modern approaches. There are the statement of problem that created by aquaculture management gap. Improper management has led to increased waste and chemicals level in water bodies. Traditional limit insufficient for modern intensive farming. Modern barriers, technological and financial barriers make modern method inaccessible to all. The goal, finding sustainable solution by comparing various control approaches. There are some major sources of pollution in aquaculture: organic waste, uneaten feed and fecal matter that decompose into harmful ammonia nitrates, chemical pollutants, improper use of antibiotics, pesticides and fertilizers, physical pollutants, suspended soils and turbidity that reduce light penetration for photosynthesis, biological pollution, spread of diseases, parasites and non-native species. There are some impact of aquaculture, pollution, water quality, nutrient buildup lead to low dissolved oxygen and toxic algal blooms, organism health, chronic stress, disease outbreak and mass mortality, ecosystem damage, untreated effluent discharge harms wild biodiversity, human health, chemical and antibiotic residues in fish product. There are some traditional approaches in aquaculture. Natural reliance focus on low input system and natural processes, water exchange using fresh water from rivers or rain to dilute waste and boost oxygen, low docking density, fewer fish per unit area result in naturally lower waste production, polyculture, stocking species with different feeding habit, surface bottom column to minimize waste, natural bioremediation, aquatic plants, duckweed and water hyacinth absorb excess nutrients, filter weeders, organism that clean suspended particle. These are the picture of traditional method in aquaculture. Now my friend Rosita will continue the modern approaches.
Thank you. Thank you, Uspandita. So moving on to the next part, I will be talking about modern approaches for pollution control in aquaculture. Now let's look at some modern approaches used in aquaculture. Recirculating aquaculture system, water is reused through mechanical and biological filters, remove ammonia and solid waste within the system. The main benefits prevents the release of polluted water into the environment. This is the picture recirculating aquaculture system. The next part, the next important method, bioflow technology. The mechanism maintains a carbon and nitrogen balance to grow beneficial bacteria. The function is bacteria convert toxic waste into microbial protein. The integrate multi-trophic aquaculture, waste from one species becomes a resource and another mussels or seaweed. Digital monitoring, sensor track dissolved oxygen, pH and temperature in real time. Biofertilizer and probiotics, use of specialized filters and beneficial bacteria maintain health. Comparison between traditional and modern method. In traditional approaches, the method is natural process. In modern approaches, the method is scientific technology driven. In traditional approaches, the cost is low cost. In modern approaches, cost is high. In traditional approaches,
1 minute more.
In traditional approach, the efficiency is limited in high. In modern approaches, efficiency is high efficient waste removal. Now I conclude the presentation. Aquaculture pollution is a major challenge that requires effective management. Traditional methods are eco-friendly and cost-effective,
please keep silence.
limited in productivity, and modern approaches offers efficient pollution control and higher yield, but require investment and technical skills. Thank you.
Thank you. Any questions from audience? If there is no questions, let us thank Ms. Uspandita Phukon and Prajita Das for her presentations.
Thank you.
We'll move to Dr. Nivedita Gogoi for the next participants. We have one more candidate only, so I think it's fine. Okay.
Yes? নাই নাই তলত আছে মই উলিয়াব পাৰিছোঁ এইটো চৰি স্লাইডছ কৰি দিবা আপোনাক এইটো পটত নহ'ব নি উল্টাই দি আছে নহয় হ'ব A very good evening to all of you, respected chairperson, honorable principal ma'am, respected dignitaries, my respected teachers, and fellow participants along with the dear students. So today I'm going to present my paper on solid waste management scenario in Jorhat, its challenges and prospect. As all of we know about the solid waste which has created havoc in our society, which are daily used to generate by our various activities, and their management is utmost important because whenever they are used together in our society, then they would create certain health as well as environmental hazard. So I have selected the topic because in our Jorhat, as we know, it is the cultural hub of Assam, and due to rapid urbanization, the population of Jorhat is increasing day by day. So as a result, the enormous quantity of solid waste is also generated in our society. So their controlling measures are very much lacking. So I have selected the topic, how it could be managed, or what are the challenges we are really facing by the solid waste in our society, as well as what could be the prospect of this solid waste. So solid waste management is the systematic, administrative and functional control of the generation, their collection, their transport, processing and disposal of this waste from our society, and it used to create certain type of health hazard, as all of we know about the Donara air pollution as well as Love Canal tragedy, which has created the unscientific way of dumping of solid waste. Certain type of environmental hazard has occurred. So their minimization is utmost important, and it is the need of the hour. So as we know, the dumping of the waste in our society creates certain type of gases they used to emit, and which may affect our environment by creating climate global warming, as well as they are mainly responsible for our greenhouse phenomenon. So in that concern, I have selected our residential area, that is Jorhat, for our study, and which is, all of we know, it is a capital of the Jorhat main city. Jorhat city is situated geographic location in between 26.75 north and 94.20 east latitude, and it is the headquarter of the district, and being a cultural capital of Assam, and it is the second largest city after Guwahati, and the rapid urbanization, these are the reasons the population is greatly increases day by day. So as a result of that, 39 tons per day of solid waste used to generated in this city, and which is quite expected that within 2035 it would be 58 ton per day of solid waste generation in our society, and which could be a very serious matter for us. So as we know, our Jorhat Municipality Board, which used to manage the various type of wastage generated in our society, and which was established about 100 years ago, and it is still going on, but certain type of lacuna is there, as a result of which we used to see different type of gatherings or certain type of huge dumping in our certain places, and which create certain type of we loses our aesthetic sense in that condition. So as according to our 2011 census, the population of Jorhat is 1,53,889, and which is obviously increases after it is about 2011, and now we are in 2025. So, and the literary rate is about 91.8%, which is quite high in comparison to other districts. So, in that sense, or as a capital of cultural capital, we are facing certain type of issues in this regard. So there are total 19 wards in our Jorhat municipality area, and different type of situation we are daily facing in these conditions during this solid waste. So for my study, I have selected this objective, that is how the solid waste used to generate and how we could classify them, and what are the environmental or health issues could be or arises from this solid waste, as well as what measures could be adopted for sustainability. Secondary data has been collected by myself from the Jorhat Municipality Board, as well as photographs has been taken by surveying different area, and interview is also interacted with the municipality workers, then the data are gathered in this manner. So during my results, I have found that different type of waste generated, which is from our household itself. Then other wastes are also generated from municipal areas such as marketplaces, as well as construction waste. And e-waste is another serious issue for us, as well as hospital waste is another waste. Then we can classify the sources of garbage collection, that is according to the 2016 Municipal Solid Waste Management Rule. That is, we can classify them into two categories. This is primary source and secondary source. Primary source is the source from where...
Madam. Sorry to...
Yes. From where we can collect the substances directly, and the secondary source from where we used to dump our substances in certain type of dustbin. So we have different type of municipality. Jorhat municipality have different type of trucks, two numbers of truck, or in comparison to the population, it is very few. I think that dustbins are 65 numbers, and as all of we know about the dumping ground, we have only one dumping ground, Kokopai, about 6 to 7 kathas of land, that is the Gormur, and which has created certain type of situation, health hazard in that particular area, and without any boundary, it has certain type of spreading at that area and directly affect the health hazard to the surrounding people. So it has created certain type of, the people, different type of animals are used to inhabit in that particular area, as well as dumping yard is increasing day by day due to the increasing population. Excuse me. Then certain type of unhygienic condition has been arised, and in some period, some people used to burn them. As a result, certain type of gases, very toxic, carcinogenic gases are produced from that area. So we are facing some problems, because whenever we are throwing our waste by ourselves, then we never screened it out, whether it may be biodegradable or non-biodegradable. It has created certain type of problem in that sense for dumping area. So then absence of proper collection method, then inadequate infrastructure. I have mentioned very few infrastructure is available in our area, as well as limited land availability. Then indiscriminate dumping of waste, that is, we are not separating the different type of waste which are environmentally certain type of hazardous. Then financial constraint is obviously there. Then general lack of awareness. This is the most important one. Then these are the ways. Then waste segregation must be there. Then it could be minimized. Then waste transportation. Whenever we see the trucks or vehicle who are carrying all those things, they are without any kind of covering, or they are uncovered, and they are certain type of substances they use to fallen down from the truck, or they are very stinking one. So they are the main problem in transportation, as well as waste disposal is another cause, that is the biodegradable or non-biodegradable we are not separating. Then these are the manpower in municipality area, which is very few in comparison to the huge area. So these are the dumping side. I just want to show the different type of birds. They are the greater adjutant stock they used to inhabit in that particular area. Very beautiful bird, but the site is quite terrible. Then this is the one picture which has created certain type of health hazard. Health hazard. So one calf, he used to consume the polythene, and the veterinary doctor who has made surgery over there, and this is the condition which the calf used to face, and this is the condition which we generally see in our locality. And this is the image of TR Fukon Road, and this is the one dustbin storage area, and this is our Tuklai River, and this is the prospect. And with this, I will wind up. That is the prospect. So one road is made up of plastic. This is the one great prospect, and it could be used that is the organic waste which could be used as a composting by aerobically decomposing it, and another one is biogas could be generated, and energy could be generated from the waste. So that's I wonder. Thank you, sir.
Okay, thank you, madam. Thank you. Did you make any household survey to find out this waste disposal pattern by the local people?
Yes, sir.
Did you make any household survey to find out the waste disposal pattern by the local communities and all?
I have made, sir.
Made, okay.
They are not segregating the biodegradable and non-biodegradable one.
Okay.
The major reason. And people used to come, but they never come in a regular manner.
Okay.
Sometimes they used to come, and whenever I ask them that why you are not coming regularly, then they will say, where we used to dump all these things. So they used to make certain type of gate.
Yeah, yeah.
That's a major issue.
Yeah.
Thank you.
Okay.
Thank
so
you.
any more questions? If not there, then we'll thank you, Dr. Nivedita, madam, and then we'll move to the next participant, Dr. Debanusi Datta.
Can কাম কৰা নাই না মোৰ মস্পেটটোৱে এইটো কাম কৰা নাই মস্পেটটোৱে কি কথা আনি দিলে বেয়া হ'ব না ইয়ালৈ নিব লাগিছিলে তেতিয়া এইটো নাই কাম কৰা মাউচ এটা লাগিব এইটো কাম
offer my heartfelt gratitude to the principal sir for giving me an opportunity to present my findings. So my topic is on exploitation of gluconate capped silver nanoparticles for post-harvest disease management. So we know silver has a diverse antimicrobial activity. That's why it is used in medical sciences as well, and also in food processing and food processing sectors. So we know the post-harvest losses is a very important aspect in terms of economic point of view. So mainly fruits and vegetables are affected by different fungal and bacterial strains. Molds, yeast, bacteria are the major biotic factor causing post-harvest diseases, and to overcome this problem, we take up one experiment, that is synthesizing gluconate stabilized silver nanoparticles to inhibit the growth of your post-harvest pathogen. So we know penicillium is a very important penicillium species, aspergillus. These are the very important pathogen causing post-harvest decay. So my experiment was based on the khasi mandarin. It is one of the important fruit crop growing all over India, and mainly the northeastern region, and the state Meghalaya is actually the place with this unique germplasm. For that it attained the GI tag, and that's why I take up this experiment. And moreover, the off-season availability of this fruit is very, very less. And also, to increase the shelf life, generally commercially what people do, they are going for wax coating. And during the wax coating, some of the pesticide they are using, so that they can increase the shelf life of the fruit by minimizing the growth of your pathogen. During that wax coating, due to addition of that pesticide, they cause different type of health hazard to human body. So to overcome this problem, we are trying a new aspect, that is the nano coating. With the help of nano coating, so we can enhance the shelf life of the fruit. So very limited work has been carried out in this aspect. So with that, we have kept two objectives, that is the synthesis and characterization of gluconate stabilized silver nanoparticle and to assess the efficiency against the post-harvest diseases. So these are the methodology that we have followed for synthesizing the gluconate capped silver nanoparticles. They are step-by-step procedure. So since time is limited, I'm discussing the main points. After that synthesis, we are characterizing the synthesized silver nanoparticles with the help of TAM, SAM, FTIR. These are the different technology we have followed for synthesizing, characterization. After that, we are going for testing the in vitro efficacy against the post-harvest pathogen with different concentration, right from 1 ppm to 5000 ppm we are taking. Then after that, we are going for nano-coating of the Khasi mandarin with the suitable concentration in different duration, that is 30 seconds, 60 seconds and 120 seconds. Then after that, we are going for evaluating whether this is actually working or not by estimating the disease severity index. So these are the scale we have followed for estimating the disease severity index, and this is the formula. Then coming to the results, while synthesizing, we have noticed the color change of the synthesized silver nanoparticles. It is changed from yellow to the brownish in color. So it gives one hints that our silver nanoparticles may be synthesized. For further confirmation, we go for different characterization technique, that is TAM, SAM, DLS. These are the different characteristics where we have got the size is about 94 nanometers with negative zeta potential of minus 15 millivolt. Then these are the different post-harvest pathogens we have isolated from different fruits and vegetables. These are the Aspergillus fusarium, then penicillium. These are the important post-harvest pathogen. We are testing these silver nanoparticles against this pathogen. Then we have found that at 250 ppm, it gives the highest inhibition of the penicillium. It is one of the important pathogen which cause the blue mold disease. Whenever we bring the oranges from the market, generally it is infected with the penicillium. So our main target was the penicillium, how we can inhibit the growth of the penicillium. So we have tried different concentration, and on that 250 ppm give the highest inhibition of the pathogen. After that, we go for
one more
nano-coating.
minute, madam. Okay.
We go for nano-coating. Then we have found that in uncoated food, the highest disease severity index was recorded. Then we have observed in different duration, that is 4, 7, 10 and 14 days after inoculation of the pathogen in the nano-coated fruit. And the lowest inhibition was found in the treatment 3, that is nano-coated for 120 seconds with the penicillium inoculum. And it gave the lowest disease severity index, that is 16.6 for 120 seconds. So coming to the conclusion, that is synthesized silver nanoparticle have a strong antimicrobial activity against the post-harvest pathogen at the highest concentration as 250 ppm and the highest mycelial growth of the pathogen at 58.23%, and the lowest disease severity index was recorded at 66.6% for nano-coating at 120 seconds. So this comes the future prospect, that is we have synthesized, we have nano-coated. Our next question is, what is the toxicity level? So we have to study on that. We are studying in the toxicity of that nano-coated fruit. So thank you very much for giving me an opportunity. Thank you.
So why silver nanoparticle? Why you have chosen silver nanoparticle?
Yes, sir. Silver nanoparticles, sir. Yes.
Why?
Why? Because, sir, generally we see silver has the antimicrobial property. From long back we are using silver, and silver also used in the medicinal, and we are using gluconate capped silver nanoparticle. So gluconate itself has an antimicrobial property. So there is dual antimicrobial property, sir. Thank you.
So you have synthesized it?
Yes, sir. We have synthesized that one.
Okay.
Yes, sir.
Okay. So thank you, Dr. Devanusi.
Yes.
I think with this, we had the last presentations. Okay.
Now, few lines to the participants.
Okay, already we are running short of times. So my sincere thanks to the organizing committee for giving me this opportunity. We had wonderful presentations during these sessions, especially from the students. And with these few words, I want to conclude these sessions. Thank you very much for your kind attentions.
Before concluding, I would like to express my sincere gratitude to our respected chairperson, sir, for his valuable guidance, all distinguished speakers for sharing their research contribution, participants for their active engagement, the technical and support teams for ensuring the smooth conduct of the session. With this, I formally conclude that the first technical session is ended. Thank you all for your participation. Thank you.